The next method that we're going to learn on how to add vectors is the Pythagorean theorem. So if you are familiar with, or if you still remember the infamous a squared plus b squared is equal to c squared, and of course the power of right triangles, wouldn't be really difficult for this topic to be discussed. Okay, so let's try to solve some problem. Then at the same time, you're going to see how we are going to solve physics problems from now on. Okay, so let's say Jerry Lynn. Okay, so Jerry Lynn tries to swim, no? So she goes to the north. Okay, so let's say this is vector A. Okay, and vector A is 12 meters. Okay, take note of that. And then after that, she detoured going to the east. Okay, so let's say that would be our vector B, which is 5 meters. Okay, so first let's state the given. Okay, so this is our illustration or representation. So after determining the problem, we write the given. So first we have vector A, which is, what did I say? 12 meters, correct? Then since this is a vector, it has a direction going to the north. Then we have vector B, which is 5 meters. Okay, going to where? Going to the east. Okay, as you can see from the illustration. Then of course, after knowing that, what would be the required? Okay, so the required would be, of course, the resultant vector, which is this. Okay, so that would be R, alright, or the resultant vector. Okay, so for the equation, like what I've said earlier, this would be the Pythagorean method, but instead of using a squared plus b squared is equal to c squared, we're going to use the variables that we have here. So this would be a plus b equal to something like that. Okay, okay, now there are two parts to this answer. So first is the magnitude of the R. Okay, so the magnitude, and of course the direction of the R. Okay, so first we're going to cover the magnitude portion of the solution. Okay, so let's do that because that's easier. So substitute the values. So we have 12 meters to be squared plus 5 meters to be squared equal to R squared. Then of course square root both sides, since what we really need is just the R, or the resultant vector. Okay, so input that on our cycle. So let me grab mine. I hope you have yours as well. So let's take a look. Can you see it? Okay, so let's try to input the values. So that would be square root Okay, let me just input it. 12 to the squared plus 5 to the squared. Okay, here. Oopsie, can you see it? There. So what's the answer? So the answer is 13. Then of course, just copy the unit since you already squared them and you cancelled it. Okay, so that would be your final answer. Alright, so it would be better if you can also show the solution thoroughly, but it's up to you. Okay, but I prefer as much as possible that you do derivations on your paper, right? Especially later on the future topics that we're going to cover. So let's say you write this as square root of 144 meters squared plus 25 meters squared. Correct? So that would be 169 meters squared. Okay, which is 13. So that's our answer. Alright, so this is the A part. This one. Okay, later on we're going to cover the directions, but first let's have some review on the directions. Okay, the cardinal and secondary directions, the Cartesian coordinate system, and the trigonometric functions.